Hi guys, I'm gearing up giving the Motorola 5T13P an alignment. Now, as you can see, there's a whole jumble of wires, but don't worry, these wires are only there to provide AC power to my function generator, which is the heat kit IG102, which I discussed in another video, and the radio itself, or the chassis I should say. I also set my function generator, or the heat kit signal generator, to 455 kilohertz. Now you see it does vary a little bit, but let's face it, it's a tube functioning generator and it's not entirely stable, although I've been letting it heat up now for almost 10 minutes or so. But let's say I'm fairly close to 455 kilohertz, and I think that will serve the purpose. So the goal is this. I had a look at the alignment instructions on the schematic, and they are fairly simple and they consist of really 3 steps. But what I'm going to do now is the first of those 3. The first step involves this. I should connect the output of the function generator, or the signal generator, excuse me, to pin 7 of the grid of the converter tube. Now I had to think a little bit what they meant by converter tube, but it turns out the converter tube is this one. It's actually the 12BE6, which is connected, as you can see on the schematic, to the antenna coil and to the local oscillator coil. So what I'm supposed to do is to inject a 455 kilohertz signal on one of the grids, which is attached to pin 7 of this tube. And if you read on, if you see under the 455 kilocycle mention here, you see 400 and a squiggle and then mod. I think they mean that you should modulate the 455 kilohertz signal with a 400 hertz audio wave. Now my IG102 has an internal modulator, and that generates around 300 hertz. That should be just fine. I don't think it really matters a lot whether it's 300 or 400 hertz modulation. And then they say that the tuning gang should be fully open. Now again, I had to think a little bit what they would mean by tuning gang fully open. I realized that they were probably talking about the tuning capacitor, which you see here, and that the plates should be completely open. In other words, if you turn it counterclockwise, you close the oscillator, what am I saying? You close the variable capacitor. If you turn it clockwise, you slide the movable discs out of the fixed discs of the variable capacitor. In other words, you open up you open it up completely. So I think I interpreted it correctly by setting it like this. If any one of you has a different opinion or has a tip about this, then please let me know, because it does sound a bit confusing when you read tuning gang should be fully open. Anyway, what I then should do is to measure voltage across the voice coil. Now in a radio there can be only one voice coil, and that's the speaker. So I attached the multimeter, you see over there, to the output, or well, the output of the audio transformer, which goes to the speaker. So I did that too. Now the very last thing they mention is that I should adjust A1, A2, A3 and A4, and I should adjust for maximum output. They probably mean that I should hear maximum volume. So in fact, I should also see maximum readout on my multimeter. Now, again, it might be a little bit confusing what they mean by A1, A2, A3 and A4, because that would suggest 4 IF cans, while in fact on the radio chassis there are only 2 IF coils. And once again I realized that there is a hole on top of the IF can. You can't see it just there, but on top of the IF can there is an opening. But if you turn the chassis on its side, then you see 2 holes. You see a hole here and you see one here. Now these 2 holes, as it turns out, go right down and up into the bottom of the IF cans. So in other words, you can find the coils respectively A2 and A4 via the bottom of the chassis, and the coils A1, which is on this IF can, and A3, which is on this IF can, via the top openings. So that's exactly what I'm going to do. The frequency of my signal generator is not entirely stable. As you can see, it fluctuates by a couple of kilohertz, either up or down. Despite the fact that I've been heating it for about 20 minutes now, it doesn't seem to be entirely stable. The frequency you see right there is about the best I could get out of it. And by best I mean the closest to 455 kilohertz. Anyway, what I'm going to use to set the IF coils on the chassis is a little tool like this, which is really nothing more than a sort of a plastic screwdriver with a flat end on both sides of the shaft. So you have a flat end here and you have a flat end here, and the only difference is that one end is a little bit wider than the other. So I'm going to use this to align the IF cans. Now the schematic says that I should hook up the signal input to the pin 7 or the grid of the converter tube, which is the 12B. Despite my best efforts to align the Motorola chassis, I haven't been very successful until now. let's say it has marginally improved on reception, but it's still not perfect. So I realized when I had a look at the schematic of the Motorola that there were still a few capacitors I had not replaced on the chassis. Let me see. So, if you take a close look at the schematic, you see that next to the coils of the IF cans, there are capacitors drawn. And until now, I had always postponed changing them. So, although I'm not certain that these might be the ones that are thwarting my efforts to align the radio, I think I'd better have a look at them and maybe change them anyway. Right, so that's for the electronic part. Now for the mechanical part. You remember that on the cabinet of the Motorola there is a piece broken off, as you can see here. And it's not really what you could call a clean break, but it's salvageable. So I thought about it a little while, about how I should go about repairing it, and I came up with an idea that I tried many years ago and that worked rather well, and that is that. Now, I don't know if you can see it clearly, but this is a sheet of glass. It's glass of 1.5 millimeter thick. It's just normal glass, nothing special. And you can buy it at any home improvement center or even in a tool shop. So what I'm going to do is to cut a sliver, say 3/4 of an inch high, so up to here, so about up to here. I'll cut it off the bottom of this glass plate twice, and then I'll use the slivers to plug, as it were, the gap, the hole. Yeah, like this. So I'm going to put a piece of glass at one side, and I'm going to put another piece of glass this side. And on the glass I'm going to apply a very light coating of oil. Any oil will do, I suppose, but if I have linseed oil, I will use linseed oil. If not, well, I'll just use some regular cooking oil. Now, the point is that you need to coat the glass so that the epoxy, which I'm going to use to repair this break, doesn't bond with the glass, obviously. So, and once that is done and the coating is done and I've clamped the two pieces of glass on either side, I'm going to pour in just enough epoxy to fill up this hole here. Then I'll leave it like that for the epoxy to harden. The type of epoxy I'm going to use takes about 48 hours to set completely. And once the epoxy is completely set, thanks owing to the coating of oil I'll have applied to the surface of the glass, I'll be able to just lift out the glass and leave a piece of hardened epoxy which covers just this space. Once that is done, I'll just need to cut a hole with this shape with my mini drill and I'll be done. Now, although this may sound a little bit simple, there is one problem. That is the coloring. So, as you can see, the whole box or the whole cabinet has a sort of a pinkish beige coloring, and until now I don't know what I'm going to do or how I'm going to manage to have the same coloring in the epoxy I'm going to use to plug up this break. I ended up unsoldering one of the IF cans, and it had a bit, well, it wasn't that easy. I finally resorted to pulling off the cap as far as I could unsolder it, and then I cut the little tab which was grounding the casing of the IF can to the B- of the chassis. I resorted to cutting it because I felt that if I would pull even harder, I might damage the traces on the chassis, which I didn't want to do. Now, as you can see, I finally managed to open up one of the IF cans, and I presume the other IF can looks just like this one. Now, you'll remember the reason why I unmounted it was to have a look whether I could find the capacitors which are mentioned on the schematic. As you remember, there are two capacitors mentioned here and there, and the same on the other end, here and there, on the other IF can. Now, try as I might, even if I look very closely with a magnifying glass, I cannot find any sort of capacitor. There is one possibility left, and that is that under the coil rod, which you see here, at the base there's a little plate, and I don't know if you can see it, but let's see with a little bit more light. You can see that the coil is standing on a sort of a translucent base, and that base is held on with an infamous snap-on, like you see down here, one of those infamous snap-ons. Now, below that base I can see something, but I'm just not sure what it is. Now, the point is that base is held on by that snap-on case, so there must be something under it. The problem is, though, that unless I utterly destroy the base by loosening up that snap-on and everything, I see no sensible way of undoing it to open up the case to reach the capacitors inside. In my opinion, without doing any sort of significant damage, this is simply not possible. Not possible at all. And I can feel the tube which holds the cores, the IF cores, is already a little bit loose. So I suppose I could unsolder the ends of the coil and then pull the tube loose, but all things considered, these things are so delicate that even if I went about it very carefully, I'm still afraid of damaging it. So that leaves me with one final option, which is to solder this back into place, but without the cap temporarily, and then experiment with capacitors on the IF coil to see whether that will improve reception of the radio. I doubt it, but well, like I said, short of destroying the base of the IF coil, I don't see any other way of doing it. So we're back to square one. I'm sorry. Well, my curiosity took me all the way. I decided to grind loose the coil from the base, and then with a ball-headed grinder grind out the cap which was held on top of these. Now, as you can see, there was effectively between the base and the base top, or the cap effectively, there are capacitors. And it turns out to be a mica shaped capacitor, like you see here, a thin layer of mica with I think it's a silver foil in between. And the base feet, as you can see, have a flat end, and that flat end makes contact, or made contact, with those capacitors. So effectively there are capacitors involved, only I don't know why they made it extremely hard to get at. So this is certainly not a job for the faint-hearted. In fact, I would say it's even, you really need a good dose of courage to start with it, because if you're not careful, you can really ruin the whole thing. So I took every precaution I could. First of all, grinding loose the tabs that go to the IF coil. Of course, I marked where each contact will go in the end. I mean, I made corresponding markings on the foot of the base, which correspond with the markings of the coil, so I can find it back. So that's okay. Now, I have, of course, a problem. That is that on this capacitor there is no marking whatsoever as to how much the capacitor is. I mean by how much, I mean how much picofarad, because obviously this can't be a very large capacitor. So how many picofarads are involved here? Now there are two caps involved with this coil, and it's parallel with each coil. So if anybody out there, if any of you, my dear watchers, have an idea as to how much picofarad each one of these capacitors is, please let me know. In that, because then I can continue repairing this IF coil. Well, like I said, the point is you really need to unhook the IF coil from the base, and I did that by cutting the tiny little tabs here with a small grinder wheel, the one you see here, of my mini drill. And then you need to undo the top of the base so that you can reach the capacitors underneath. So the way I did that was to grind with a ball grinder from the underside until this copper holder slid through. So there you go, that's how you do it. But I advise you to really go carefully, because if you go too hard and too quickly, you might really ruin a very delicate, very brittle IF coil. So there you are. Stay tuned for another update to come soon.